video, we're going to talk about how to do transformations of exponential functions. So remember, exponential functions have different subfamilies because they don't all have the same parent function. Exponential functions are grouped into subfamilies that have functions with the same base. So when you're solving problems, you'll always be given the parent function. So for example, it'll say something like, what happens when f of x equals 2 to the x? So that's this parent function of the subfamily is transformed to g of x equals 2 to the x minus 4. Or what happens when h of x equals e to the x, which is another parent function of the subfamily that has base e, is transformed to p of x equals e to the x plus 3. So transformations of exponential functions are once again going to come in three types. We'll have shifts, which are translations, stretches or compressions, and reflections. So we're going to look at these different values to see what happens when we transform our function. We are going to have we could have an x plus h or an x minus h, or we could have a plus or minus k on the outside of the function. So describe the transformation that takes function f to function g. So here it gives us the parent function of the subfamily, which is 2 to the x. And then here we have the transformed function, which has this minus 5. Okay, so this is what gets confusing, I think, when we're looking at exponential functions, is because there's already a number there, that 2, but just keep in mind that that 2 is not a transformation. Okay, the 2 is in the parent function. So that just means that's what the base of the exponential function is. Okay, and I think that's where people often get confused when looking at exponential functions, is because when you're looking at this, you want to look at what's different between the parent and the transformation. Okay, so the only thing that's different is that minus 5. So that's the only transformation that took place. So for the minus 5, we're going to use our study guide to help us out. So you can see that's on the outside of the exponent. So that's going to be a shift down. Okay, so I'm going to say that this graph is now shifted down 5 units. Okay, and so what we can do is go to Desmos and graph this to make sure. So I'm going to graph the parent, which is 2 to the x, and then the transformed function, which is 2 to the x, and then minus 5. And you can see that this graph is in fact shifted down 5 units. So now you can go ahead and pause the video and try doing this example on your own. So here we have a 3 that was added in front of the e to the x. So that 3 represented a value of a. So that graph is going to be vertically stretched. When we look at the original, the parent function in e to the x, which is in green, and the transformed function, you can see that it is in fact taller than the parent function. So now it says the function f of x equals 3 to the x is vertically compressed by 1/2 and shifted down 4 units to form g of x. Write the equation that results from this transformation. So here we have two transformations. We have a vertically compressed by 1/2. Remember, a vertical compression means a is between 0 and 1. So I'm going to go ahead and label this as a value of a. And then it says that this is also shifted down 4 units. Down 4 units means we have a minus k. So I'm going to go ahead and label that also. And let's plug this all in. So we have a is 1/2, and then we have minus k, so that's going to be a minus 4. So now we need to go to the parent function, okay, that f of x equals 3 to the x, and then apply the transformations there. So this is going to be g of x equals 1/2 times 3 to the x, and then we have that minus 4 on the outside. So let's go ahead now and see that this does in fact represent this transformation. So we have the parent function 3 to the x, and then we have 1/2, and then times 3 to the x, and then we close the parentheses and put the minus 4 on the outside, and you can see that this graph is in fact vertically compressed because it's flatter than the original graph. It's shifted down 4 units, and you can see that our equation does represent these transformations that are described. So now you can go ahead and pause the video and try doing this problem on your own. So here it gives us the parent, which is e to the x, and then it says that e to the x is reflected over the x-axis and shifted right 5 units. Remember, if something is reflected over the x-axis, that means that a is less than 0. So that's why we put this negative in front. And remember, if it shifted right 5 units, that means we have an x minus h. So when we go ahead and type this in Desmos, I just want to show you how to type this because sometimes this can be a little bit misleading. We have e to the x, which is our parent function. And if you go to type in negative e to the x minus 5, I want you to make sure that you're putting that exponent in parentheses. Okay, so it should be like this. You do exponent and then parentheses x minus 5, because the problem is if you just do negative e and then do the exponent and then you just type x minus 5, you see how it puts the minus 5 right here? That would be a minus k. Okay, so to get that minus 5 to be in the exponent to reflect the horizontal change, you have to put that exponent in parentheses. Okay, so you can see that when we write the function correctly, this is actually reflected over the x-axis and it is also shifted to the right 5 units. So remember, by looking at the equation of an exponential function, you can determine the transformations depending on how the values of a, h, or k are changed. Remember to group functions into subfamilies to compare and study transformations.